Now let's look at how we can use this software to do virtual labs. Um, okay, let's look at the first question of this lab. You may have noticed that you can dissolve more sugar or table salt in hot water than in cold water. This is because the solubility of these substances increase with temperature. But is it always true that solubility increases with temperature? The stockroom contains these two solids. Does the solubility increase with temperature for these substances? Okay, so this is a question. Now let's look at how we can use this software to do the virtual lab. First, we go to File, we load homework, and then the first lab is in the category of solubility and then solids. And then we can choose the first one, right? Temperature and solubility of salts. Double click, and then we reach the page, and then we can see all the materials that we need to do the virtual lab. Now we can start to do the first lab. Okay, we want to find out first. We want to work on potassium chloride. Okay, we can first figure out the solubility of potassium chloride in water at 25 Celsius degree. For solids, normally the solubility refers to the maximum amount of solids that can be dissolved in 100 milliliter of water. Then here we put 100 milliliter of water. Okay, 100 milliliter water, and we want to find out the solubility of solid in 100 milliliter water. But here we can see they're all solutions. You see, they're all solutions, and we choose this one, potassium chloride. Okay, and what we can do first is to remove liquid. Then we only get solid, right? And here we can check solid, and then it tells, well, I myself don't like this small font size. Yeah, if you know how to increase the font size, please let me know. You see here, the left potassium chloride weighs 1.5658 E2 gram. You see the unit is gram. This is a scientific way of describing the weight. E2 means 10 to 2. So we can see the potassium chloride here weighs 156.58 gram. Okay, we need to write this down. And then before we do the experiment, we can first check one figure in the textbook. It shows the solubility of a few solids in water at different temperatures. Here we want to figure out the solubility of potassium chloride at 25 Celsius degree. You can check the figure and see that the solubility of potassium chloride at 25 Celsius degree is around 36-35 gram. Okay, just about. Actually, we don't need to know the exact amount because we can figure out here. Okay, before we do the experiment, we need to go to check the solubility, the temperature, because we want to figure out the solubility of potassium chloride at 25 Celsius degree. Then we set up the solid 25 degrees. Same thing, we want to set up the temperature 25 Celsius degree. We don't want to check the second one. The second one insulated from surroundings, meaning the temperature will not be constant. So you can just imagine when potassium chloride is added to water, the temperature may increase or decrease because the dissolution either is an ectothermic or endothermic process. But here we want to know the solubility at 25 Celsius degree. Then we keep the temperature 25 Celsius degree, and we don't choose this insulated from surroundings, because if we choose this condition, then the dissolution process may increase or decrease the temperature, and that's not what we want. But this can tell us some information. Okay, we choose OK. We click OK, and then we do the transfer. OK. We can see here at the bottom. You see that at the bottom we can choose amount. We know 100 milliliter of water can dissolve 35 or 36 gram, but we don't know the exact amount. Then we can just put 50. We can just put more than necessary. Okay, 50 gram. Here sees transfer amount 50 gram, and then we pour from potassium chloride solid to 100 milliliter of water. Then we do pour. But before we do that, you can see the temperature here above 25 Celsius degree, right? 25 Celsius. Then we do the pouring. Okay. Immediately after the pouring, you can see the temperature decreased to 10 degrees something, and then goes back. See that? The temperature is going back, and you can see the amount of potassium chloride in the container, kept decreasing. You see that? Because as we pour solid, as we pour potassium chloride, then the amount of the potassium chloride in the solid container decrease, and the temperature now is going back. Remember, when we first pour potassium chloride, the temperature of the solution decreased to about 10 Celsius degree, and then the temperature goes back. You can think about why is that? Is the dissolution endothermic or ectothermic? So here, as we keep pouring potassium chloride, the potassium chloride in the solid container keep decreasing. You see that they keep decreasing, and then the temperature slowly goes back, because we want it to reach 25 Celsius degree, right? Because we want to measure the solubility of potassium chloride at 25 Celsius degree. See, it's 24.88 Celsius degree, the temperature of the solution, and the solid from the solid in the potassium chloride in the solid container is still decreasing. The amount still decreasing slowly. Okay, we see 24.97. Okay, the temperature 24.98 Celsius degree is approaching 25 Celsius degree. Okay, 24.98, 1.4 to 1.3. Okay, now the temperature reaches 25 Celsius degree, and the potassium chloride left in the solid container does not decrease, and we can stop the experiment, and we can remove. We can take this back, and then we can check. We can click this bottle, and it shows the left potassium chloride is how much? Is 1.0658 E2 means 10 to 2. Then we have 106.58 gram. So it makes sense, right? Because we pour 50 gram, right? We pour 50 grams of potassium chloride, and that's what is left in the solid container. And then we can check here. Here we can see the potassium chloride. You see, it's solid, right? It's solid. The potassium chloride solid in this solution, in this solution is 1.4 to 13 E1, means 1.4 to 13 times 10 to 1. So the solid in the solution is 14.213 gram. That means this solution is saturated. The solution is saturated because this solution has excess solid inside. Okay, here we when we click this bottle, and then it's potassium chloride, right? And then it shows on the right the potassium chloride has that amount left. And when we click this solution in the Erlenmeyer flask, it shows 100 milliliter distilled water has solid potassium chloride, solid 1.4213 E1 on the left, right? And then it's 14.213 gram. Remember at the beginning we poured 50 gram of potassium chloride, and then here we find that 14.213 gram of potassium chloride is left as solid. You see, as solid on the top right. We check solid, we can find the solid. Then we can do the simple math to find how many grams of potassium chloride is dissolved in 100 milliliter of water. Then it is what? It is 50 minus 14.213 gram. Then we'll get 35.8 gram of potassium chloride dissolved in 100 milliliter of water, and that is the solubility of potassium chloride in 100 milliliter of water at 25 Celsius degree. And we can do similar things for the solubility of other materials and then at other temperatures.